Hi there, I have an interesting problem for you, and let's see how we can solve it. So I have all of the AIs being symmetric on the fx, and all of them are real numbers, and fx is greater or equal than 0 for every x, and then this implies that a1 is equal to a2 is equal to a3. So let's see how we can do it. Well, I can think about this like if I had a function gx that g prime of x, if g prime of x would be equal to fx, which means gx is integral of fx, if this was true, so this is greater or equal than 0, and by the derivation test, I would say gx is increasing. Gx is increasing. So if I can find such, if I can find one g function that satisfies this condition, I will know that gx is increasing, and maybe I can work with that. So as I said in the beginning, fx is symmetric, and it's not so hard to see that if we pick gx being equal to x minus a1, x minus a2, x minus a3, then if I take derivative of this, I will get this fx. I can also add any constant, but I don't really want that. Even if I don't add any constant, this function satisfies this condition, and gx is condition. Gx is an increasing function, and this is the value that is most useful for me. If I add something, you will see that it's not going to help me. So I know that gx is increasing. So let's try to graph it. Okay, this I'm just graphing it randomly. This is not gonna show anything correct, but what I know about a cubic function, so this has degree 3. I have 3 x's. So if x goes to infinity, this will go to infinity, and if x goes to minus infinity, this will go to minus infinity, and this is a continuous function. And I know that this is increasing, it's not going down or something. Okay, so it's always going up. So this function has to has only one root. Okay, it has to has one root. Every cubic function has at least one real root, and it has to be only one root because this function is increasing. Okay, so therefore now I have only one root, and from here I know that I have roots of a1, a2, a3, because if I put x is equal to a1, I'm gonna get 0. So if I put x is equal to a2, a3, I'm gonna get zeros. So a1, a2, and a3 are zeros of this polynomial. And since I only have one root, let's say this point is a has to be equal to all of these points, okay? A is equal to a1, uh, which is equal to a2, which is equal to a3. And that's the end of it. So I can only have one such AI values.